All right, so we're in AP Calculus. Today's date is Friday, October 4th, which means it is a minimum day schedule. So we have 10/4. Our objective, someone read it.
Identify what height, slope, and concavity means in function notation.
Yeah, so you have a cavity, like in your tooth, but it's concavity. So we don't even know what those words mean, but let's first look. Yeah. What is height? So we know height, right? If I say I have a point here, then I know that the height is over here. So I can say that that is the height. I can spell GHT. What does it mean for slope? So if I look at I can do this in red, I guess. If I look at the slope, this thing right here is the slope. Nice and easy. That is the slope. Thank you. And the concavity at this point is what type of curvature you have. So if I'm starting to curve down, then it's concave down. So concave down in this case. Do you guys see where it's concave up? On the other side, yeah, like all of this stuff, that's concave up, that's concave up. We just usually do an arrow. I try to do orange for concavity, and then all this stuff is concave down over here because it's curving down. Do you see where it's neither concave up nor concave down? There's one specific point where it happens. Right there, yeah. This one doesn't have any concavity right there.
The origin.
The origin, yep. Cool, so now you know what concavity means roughly. Let's go ahead and the height, usually when I say height, I'm talking about the y coordinate. Y coordinate. The slope, what's another word for slope when we're talking about calculus? Rate, that's still kind of like a physics-y term. What is the calculus term? Keep going, keep going. Just for the T.
F prime. No.
F prime, yeah, let's do F prime. I like F prime. F prime of X. What's another one? Oh yeah, let's say derivative. Well, we have to be careful about derivative, but yeah, we'll say derivative. That kind of changes this unit. Derivative, and the thing I was looking for is tangent. Concavity, just know that you're either going to have like a concave up, that looks like up, or concave down. Down.
This class was kind of
Feels weird? Okay. So we have three graphs and then we're done. No backside. So here are the three graphs. If I have a graph of f, it's what we're used to. Nothing is new. So if I'm looking at a graph of f, you basically are looking at this graph that we just did for vocab. So height. If I'm looking for height, that is f. This is going to change, I promise. This is going to get harder and confusing. This lesson is usually where everyone starts to get confused on 3-1. Make sure we have good basis. Height is f. That makes sense, right? Slope is going to be what? F prime, and then concavity is going to be f double prime. We can now take the derivative of the derivative.
Oh, we're finding primes and primes. I love this.
If I take the derivative of the derivative, that is called the second derivative, and the annotation is f double prime. That's how I read this thing. I say f double prime. So if I want to find the height at A, the notation is f of A. And what is f of A? Is it 0, bigger than 0, or less than 0?
0.
So f of A is equal to 0. That's how I say that. Let's try another one. Let's do f of B. The height of B, or f of B. So I'm talking about height here in terms of concavity, or in terms of the graph of f. Don't know why I said concavity. What is the height of B? Is it greater than 0, less than 0, or equal to 0? It's less than 0. Good. What about f of C? F of C is greater than 0, and f of D is greater than 0. So far, so good. This is all kind of review up to this point. We haven't done anything new. Still going to be reviewing. If I'm saying f prime of A, the slope at A. What is f prime of A?
Less than 0.
It is less than 0 because if I come back over here and make a line, the slope right here, let me make the right slope and then put it over here. The slope at 0 is negative. Our slope at A is negative. Let's try another one. Let's do the slope f prime of b. That's going to be what?
Which one?
F prime of b, yeah.
Equal to 0?
It is indeed equal to 0 because if I draw that tangent and move it in the right spot, that slope is 0. If I'm dealing with the slope at c, f prime of c, that is now going to be what?
Greater than 0.
It is indeed greater than 0. Right here is greater than 0. That's not the best tangent line. There we go. This can be greater than 0. And what about f prime of d?
Less than 0.
Is indeed less than 0. Let me change this to 125%. Less than 0. Let's do concavity now. F double prime of A. Now I have to look at the curvature. F double prime of A. Do I draw the arrow up or down?
Up.
I draw it up, so it's concave up, which means it is greater than 0. Which is kind of cool. Let's take a step back. If I take the derivative, and I take the derivative again, and then I plug in the x-coordinate wherever A is, I'll get a number that is bigger than 0. I'll get a positive number. That's what I'm trying to say here. If I take the derivative again, and then plug in the x-coordinate of A, I will get a number that is positive. All right, let's do another one. Let's do f double prime of B.
Greater.
It is indeed greater than 0 because if I drew my arrow, it's going up. Stego, f double prime of C. Careful here. Where am I drawing the arrow? At C, on the graph. Down, so it's less than 0. Yeah, it's negative. And Claire, f double prime of D. It is indeed less than 0. The arrow is going down. All right. So far, so good. I know. Now we're getting phantom knocks. This is where things start to get confusing. So this is where we're paying a lot of attention. So on a graph of f prime, you can graph the derivative. That should be like kind of starting to freak us out a little bit. If I look at this graph of f and I take the derivative of the graph of f, I get the graph of f prime. This is the graph of f, but I took the derivative. This is what it looks like. If I take the derivative of this graph, this is what it looks like. So now that I'm on this new graph, this graph is no longer f. This is a graph of f prime. On the height, if I do a height on this graph, I'm reading the graph now, and I'm reading the graph of f prime, and I'm talking about height. I'm no longer talking about f. I'm talking about what?
F prime.
I'm talking about f prime. This is now f prime.
So then it's an F prime, and F prime, prime.
It is indeed.
Oh my god.
There is an f prime, prime, prime.
I mean, we don't use it, but it's
F
there.
prime prime. Slope is now f prime prime. On this graph of f, if I'm looking at the slope graphically, what's really happening in terms of the notation is it's f double prime. And then obviously concavity is going to be
F triple.
f triple prime, which has a name. So
It has a
the
name.
way to,
Its name is horrible,
Isn't
right?
its name Jerk?
its name is jerk. Because it's how fast you're jerked out of your acceleration. So it's the acceleration of your, it's how fast your acceleration is changing. Another way of thinking about it is how fast are you stepping down on the gas pedal of your car? That's f triple prime. How fast is your foot moving down on the gas pedal?
Also just
If I all of a sudden just press on the gas pedal, my jerk is going to be really fast forward, right?
yeah.
Knocks off my hat. My jerk will be really fast. And if I step on the brake really fast and let go of the accelerator, then my jerk is also going to be really high. That is jerk, how fast I'm stepping on the accelerator. But guess what? We don't care about jerks in this class. That's called jerk. And you can say, we don't care about jerks.
I like that.
At least in AP Calculus, we don't care about jerks. When is jerks valuable? They're very, very valuable in BC Calculus when you're doing Maclaurin series or Taylor polynomials. Then you'll have jerks that you have to worry about. For AP Calculus, AB, we don't care about jerks. So for roughly 90% of this class, don't worry about jerks. Okay, so let's try f prime. If I'm trying to find the height f prime of A, what is f prime of A now?
Less than 0.
It's less than 0 because the height is less than 0. Look back here. F prime of A is less than 0. Your notation will match. Your notation should match perfectly if you choose the same point. Again, B and B aren't the same point now. B is over here to the left and B is right here in the center. So B and B are no longer the same point. I probably should have changed the letter here. But the notation should be the same if you choose the same x-coordinate. What about f prime of b? What am I asking for here? Yeah, that's greater than 0 because the height here is greater than 0. I'm just talking about height on the graph. How do I say the height of c? F prime of c, and that is less than 0. And I guess c is really d, the same x-coordinate. Let's do slope. What is the slope at A? F double prime of A. What is the slope at A?
Less.
The slope is less than 0. Wait, no, it's not less than 0.
Greater than 0.
It's greater than 0. Again, now I'm drawing slope. I'm going to draw it in our brand new color here. It's going to be orange because it's really F double prime here. Slope on a graph of F prime represents the concavity on the graph of F without a prime. I'll say that again because it's kind of cool. The slope on this graph of f prime represents concavity on the graph of f. This is very, very important later. It's hard to think about. I'm trying to let you guys have time to digest and make sense of this. The slope on the graph of f prime, look at that slope, look at that line. This slope here is the same thing as concavity back here. If I take the derivative of concavity, then it turns into, well, that's not a good way of thinking about it. If I take the derivative of concavity, it turns into slope. So, what about f? How do I say the slope of b? How do I say that and what is it? F double prime of b is equal to 0. Yep, I agree that if I draw the slope here, it should be 0. The slope is 0. And if I draw the slope over here at c, how do I say that, Sego? F double prime of Sego? Less than 0. Perfect. And then we don't care about jerks. I'm not even going to worry about doing this. So on a graph of f double prime. So this is kind of cool. I took the graph of f, took the derivative, and I got this graph. I took this graph of f prime and I took the derivative. The derivative of the derivative is now f double prime. This is the exact same equation. If I take the second derivative, it automatically turns into this line.
So now it's going to be f double prime, f triple prime, f quadruple.
Indeed it is.
But we don't care about the triple prime, right?
We only care about the height.
Yeah, so height is going to be what? F
Double prime.
F double prime. Slope is going to be
Prime, prime, prime.
F prime prime prime. This is jerk. We don't care about jerk. And then I don't have a name for this, but it's how fast your foot is. That's not. It's the acceleration of the acceleration, not the velocity of the acceleration of the acceleration. So this is, I'll do it in green, sure. F quadruple prime. And by the way, once you get to such high primes, there's a notation for that. This is the same thing as F4 with parentheses around it. That means you took 4 derivatives. So if I do 4 with parentheses around it, that usually means that I have taken the derivative 4 times.
What is the point of that?
The point is that you know what concavity looks like.
Okay.
There is no concavity on this one though, right? Because there's no curvature. You can't have, well, I guess you can say that concavity is 0. There is no curvature. But you can't say there's concave up or concave down on the graph of f double prime here. So really quickly here, f double prime of a is greater than 0 because the height is greater than 0. And A are roughly the same x-coordinate. Take a look at your notation. F double prime of A, F double prime of A. The notation is the same throughout all of these graphs. Just what we call them in terms of height, slope, or concavity is going to change. So we're now calling this height where we called it slope back here on the graph of f prime. What about f double prime of b? What does that thing even mean? F double prime of b is the what on the graph of f double prime? It's the height of b. Yeah, so height of b is what, Claire?
0.
Is 0. And then Stego, how do I say the height of c? F double prime of c, yeah, is less than 0. All right. How confused are we? Give me a fist of 5 on your understanding. Wow, those are very high scores. I'm sure those scores will go down once you realize how hard this actually is. But yes, 4s and 5s are really good. That's it for the notes.